This tutorial demonstrates how to extract traditional land survey data from a Leica multi-station MS50 or MS60 in the DBX database format, and also to extract a digital terrain model from any scanned data collected using that same instrument. For those wishing to investigate a complete point cloud solution, please refer to the 3D Vision tutorials, but bear in mind that you will need at least Vista with point clouds in order to process full point cloud datasets. We start with a job file from a Leica MS50, which contains the DBX files, which are the traditional land survey files, together with a series of scans. We begin by creating a new LSS survey. We select Input, Download and Convert. We select the Leica DBX Reader option, and I'm going to drag one of the DBX database files into the dialog. It shows that we have one job, 121 images and 5 scans, and we're going to convert that into a LSS load file, which we can see here. I'm going to increase the error settings because I know that there are some station sighting errors in this file. There we see the survey, complete with link features and point features. And if I just change my DTM display setting to control only, we can see the set on stations and the traverse that was performed. I now adjust the traverse, set on station S1, referencing S2, and then closing back. As soon as I hit OK, it will adjust the traverse, which it has now done. And I'm now ready to import the Leica Nova multi-station scan data. In the process of reading this database, it will send back to the database the adjusted coordinates of these 3 stations, thereby adjusting the individual scans that were taken from each of the individual survey stations. Again, present one of the DBX database files. It's resized the screen and our original survey is down here, and because of a variety of outliers, there may be distant objects that the scanner picked up, the geographical limits of the individual scans extend quite a long way out. So what I'm going to do is set the area that I'm interested in by drawing a box, and it tells me that there are just over 800,000 points, and I'm going to ignore everything that lies outside of this dashed box here. The purpose of this exercise is to extract a digital terrain model. Therefore, I'm going to use the grid resample option, and I'm going to find the lowest point on a grid of 0.2 of a meter, and as soon as I select Generates, it will then extract that 0.2 meter grid of points, and from the 800,000 points we've now got 13,800. Finish, straight into an LSS load file, and load that file. And there you can see the scan data points extracted as a digital terrain model. We'll save that and then we'll go to 3D view, so we'll see remnants of a building here, which obviously is not part of the terrain model that we want. We just change the speed of movement through the model there. Okay, quite a lot of detail. So we've got the topographical detail displayed on the tree that we surveyed, plus what looks like a pretty good DTM down here where the car park and the grass is, but we've got fences, we've got dense trees over this area. So what we need to do is sample this data further, and if I put the contours on at ½ meter, we can see where these packets of information are. And looking in the bottom right hand corner, we'll see that the driveway is at about a level of 500 meters and maybe up to 500.5. What I'll do is remove observations by selection filter, and everything over 500.5 I'm going to get rid of. 3D view, same. That's it. That's sorted that out perfectly. Another useful check, if I turn the triangles on, then we might see some shadows in the data set, and what I will do is add a surface feature by length of triangle side, and I'm going to pick up void. I'm going to add a void surface feature to those triangles over 0.6 of a meter long. So in 3D view we will now see all of the blank areas not included in the DTM. So that's how to extract a digital terrain model from the Leica Nova multi-station.